we will continue with our discussion. So this afternoon, we will be discussing the Fibonacci sequence and the rabbit problem. So I know some of you are familiar with this sequence. Okay, even sa high school, we discussed naman niya siya. Alright, so before we proceed, let's have gamay nga background about this person. No? So it was Leonardo Fibonacci people, the person who created this sequence, the Fibonacci sequence. He was born in Pisa, Italy, itong Leaning Tower. And then young parents kay si Guillermo and si Alessandra. And then, so the name Fibonacci might actually come from Figlio di Fibonacci, which means son of Fibonacci. And then his major contribution, people, is katuyahang sikat nga libro, the Liber Abaci, wherein the famous rabbit problem was was written there. So na famous nga rabbit problem. So in a page in the Library of Abaci people, the famous rabbit problem appears. So here's the problem. So a certain man put a pair of rabbits in a place surrounded on all sides by a wall. How many pair of rabbits can be produced from that pair in a year if it is supposed that every month each pair begets a new pair, which from the second month becomes productive? So in this rabbit problem, people, lalo siya yung mga conditions, no? So ang first condition is, of course, ang rabbit nga ma-produce is na siya always male or female, no? And then second one is the rabbit never dies. Then the third one, katong giingon niya nga, ang katong pair of rabbit people the next month kay mahimo na siyang productive siya, na every month magsige siya produce og new pair, which is katong babae o lalaki. So mo to siya yung mga situations nga gihatag niya. So ang question is, pila daw kuno ka pair of rabbits ang ma-produce after a year? Okay, so nakuha ninyo ang iyahang problem, people? Hello? Hello? Wala? Nakuha, sir. Sige, so kato no, that's the problem, no? So I want you to answer it. No, try lang answer no, if pwede ra mo chat sa butang sa chat box, try lang ninyo. So how many pair of rabbits will be produced after a year, no? Given those situation. Number one, the pair always produce one male and one female offspring. Second one, the pair never dies. Third one, the next month kay ang rabbit mahimo siyang productive, and then every month kay mag-produce siya og another pair, one pair a month. Sige daw, try ninyo, people. After 12 months for 1 year, how many pair of rabbits will be produced? Sige, I'll be waiting sa chat box, ha? Okay. Sige ha. So, another sa chat box people, how many pair of rabbits will be produced after a year, given that the rabbit never dies? Second, always produce one male and one female offspring. Third, after a month, the offspring will become productive, and every month the rabbit will produces a new pair. So, how many pair of rabbits will be produced after a year? Sige. May baliw ko chat na answer ganiha si Jerome 144 daw. How about ang uban? Daghan man kaayo mo. Sige, wala pa yung answer. 466 sir, Jamaica, 52 pair sir, Ortiz, Rinalin 178, including ang first pair kay 180, okay? Sige pa, sa pa. How many pairs of rabbit will be produced? Pila na di ka kung estudyante, lima ra, kang uban. Hindi open your camera daw, Bi. Kita ko ninyo, Bi, kayo wala ko sure if nakapamutan na. Sige daw. Sige. Try lang, chat lang. Wala na gini problema, mabasa ako. 233 pairs di ay, sir. Okay, 233 pairs. Okay, so, sige. Isa pa. Okay. How many pair of rabbits will be produced after a year? 204, 56. Napay wala ng answer. Answer na. Ilang good wala biti mawag mo try. No?
Una ka pair. Then, ikapanganak ani. First pair mo yung first anak.
144, 144, 2,751, 144, 144, 48, 56, 204, 48, 2,584. Okay, sige. So, bayobay na ng answer, pero napayuban nga wala gid na answer. Anyway, so, this rabbit problem, people, nasulbad ni siya using the Fibonacci sequence. Actually, tungod aning problema, people, na-create ang Fibonacci sequence. Okay? So, I have here a video. Ito tanawon kung unsa ang answer niya, ha? Sige. So, let's watch the video, people. Stop share sila ko balik para makatulog mo sa iyang sound. So, kindly open your sounds to para madunggan niyo.
One, two, three, four, 5, 6, 7, 8, 11.
As a result, one new pair of rabbits is born at the end of the second month. So at the beginning of the third month, we have a total of 2 pairs. The original pair again mates at the beginning of that month, but the newborn pair does not. The original pair produces another pair of offspring, so at the beginning of the 4th month,
10,
we have a total of 3 pairs of rabbits.
9,
The original pair, their newest offspring, and their first pair of offspring, which are now adults. 2 pairs can now mate, and they each produce yet another new pair, giving a total of 5 pairs at the beginning of the 5th month. Now, 3 pairs can mate, so after the 3 new pairs of offspring are born, our total moves to 8 pairs. At this point, the sequence is 1, 1, 2, 3, 5, 8. What's the pattern? The trick is that each number in the Fibonacci sequence is obtained by adding together the previous 2. 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, and 3 plus 5 equals 8.
Okay, so what's the answer? We have how many?
44.
Okay. Okay, that's 144 pairs, no? Usually people libog sa siya usahay no kay na ibang mga libro nga mana sila after a month or after a year. So supposed to be adto ta mag-ihap sa ika-13 no kay adto man ang ma-produce ba. So usually na im answer of 233 which is also correct, no? Okay? So nasabtan ninyo naiuban nga ma-answer og 233 which is correct man kay 89 plus 144 is 233 man sa siya. Kay naiuban nga mga situations nga mana sila nga after a year man. So bigag after a year, so tinawon nimo pila ang na-produce ini ka next month na or the 13th month na siya. So naay siya 233 but ang point here people is giunsa ang process, no? So it could be 144 or it could be 233. Yeah, kung number of rabbits ang gipangay, so that's 288 or ilan 400, ilan ang 233? 466 rabbits, no? Kana siya. Okay? So sabtan ninyo people ang iyang paagi. So you just simply add the two two numbers, no? 2 numbers nga naguna niya, the 2 previous numbers ang imuhang i-add para ma-solve nimo siya. Okay?
And after 12 months,
so people, this is the Fibonacci sequence, no? So the Fibonacci sequence is given by 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and so on and so forth. No, that's continue na siya niya. The end Fibonacci sequence, people, is denoted by f sub n. So you have here the n Fibonacci is given by this one. F sub n is equals to f sub n minus 2 plus fn minus 1. So this is the n Fibonacci number. So if you are asked to solve, for example, let's say you're asked to solve the 20th Fibonacci number, so that would be f of 20 is equals to f of 20 minus 2 plus f of 20 minus 1, no? Wherein this is f18 plus f19. So of course, you need to find first the value of f18 and f19 so you could solve the value of your f20. So meaning na people, before di ka makasolve sa f20, you need to solve f1, f2, 3, 4, 5 until f19 para ma-solve mo ang f20. So if we will write that one, so that would be f1 is equal to f sub 0. No, sorry. Given naman na ang f1, no? Sorry. So let's say, for example, tingnan ka, f of 3, no? For example, f of 3 is equal to f of f of 1 plus f of 2. Yeah. F of 4 is equal to f of 2 plus f of 3, then and so on. Then you have f of 20 is equal to f18 plus f19. So medyo taas-taas gid siya og way pag solve, no? So mura ra gyud po ingana iya pamaagi, pero mura ra nag 1 plus 1, then 1 plus 2, 1 plus 3, sorry, 2 plus 3, that's 5, then 3 plus 5, that's 8. So ingana ra gid po yung paagi. Okay? So again, and always true na siya nga ang f of 1 and f of 2 is equal to 1 and 1 gina siya, people. So mo na imo ang pag-solve sa n Fibonacci, the n Fibonacci number. So here, let's try to solve, no, the first, can we generate, people, no? Can you generate the first 20 Fibonacci number? So of course, kay bao natadaan nga ang pinaka 20 Fibonacci number, people, is 6,765. So karon, I want you to generate the first 20 Fibonacci number using this formula. Kaning formula, people. Okay? So try to generate the first 20 Fibonacci numbers using this formula. So I'll give you mga 5 minutes to do that. Okay ra? So you can write it sa inyong papel or maggamit mo paint if you want, or Word, no, maybe. So sige, so I'll give you 5 minutes. So magkita tag timer dire. 5 minutes. Kay nagpaghiyo na dire. So your 5 minutes starts now. Go. So kinahanglan ninyo i-show ang value sa F1, F2, F3 up to F20 kay generate the first 20 man. Wala man gingon nga unsa ang ika-20 nga Fibonacci number. So generate man the first 20. So you need to generate that. Go. Alright, time is up. Sige. Who wants to show their work? Aneo, you want to share your work with the class? Or anyone? Sige na.
Sir, unstable ako internet.
Nadumugti ka. Sa base, no? Base Z. Hello. Mawa. Sige. Isa may ganun mo share. Jerome, you want to share, Jerome, sa mga output? Villanueva, you want?
Saan pag-share, sir? Ako, result yun. Saan ako?
Dili, wala ni mo siya gikuhan, wala ni mo siya sa di mo sa makita ang video, di mo sa mga video, no?
Isuwat na ako.
Sige lang, pwede na Jerome. Share lang Jerome, ganun sa rin Jerome. Wala lang, paal ba?
Kuhan, kanang nagsugod ko sa, kuhan, sir.
Sa
F4.
F4 kay nanay value ang 3.
Then,
Sige.
ang formula sa F4 kay kuhan. F4 equals F minus N minus 2 plus F N minus 1 nga. Moto, kuhan, F2 plus F3.
Mm-hmm.
Then, ang total na kay kuhan. 3.
Okay.
Sa F5 kay F5 equals kuhan. Gidit sa na ko F3 plus F4. So, moto, kuhan, 5.
Which is 5.
Then F6 kay F4 plus F5, 8 ang total. Then F7 kay F5 plus F6, which is 13. Then F6, F8 kay F6 plus F7, 21. Then F9 kay F7 plus F8, 34. Then F10 kay F8 plus F9, 55. Then F11 kay F9 plus F10, 89. Then F12 kay F10 plus F11, 144. Then F13 kay F11 plus F12, 233. Then F14 kay F12 plus F13, 377. Then F15 kay F13 plus F14, 610. Then F16 kay F14 plus F15, 987. Then F17 kay the F17 kay F15 plus F16.
Okay.
Then sa F7 ay ito F15 plus F16 kay 1597. Then sa F18 kay F16, F17 kay 2584. Then F19 kay F17 plus F18, 4181. Then sa F20 kay F18 plus F19 which is 67650.
Okay, very good. Sige, nya. Jerome, mga tanan sa ko, Jerome, murag, sa man mo hang na-feel when nag-solve ka, Jerome, nga medyo taas naman to siya. Nakamute ka daw.
I-dito na lang mo add ang before sa kanang number of before pa jud ay dito na lang nimo add ang first nga two
previous numbers, the first two previous numbers, no? So siguro if kabantay mo nga, so medyo taas man kayo ang pamagi, no? Taas man kayo ang pamagi ba, murag ang pag-solve na to ba, imagine na kung F100 imong solvod, niya nga na ang iyahang way pag-solve. So medyo taas kaya gid siya. So this time, people, we will introduce to you another way of solving the n Fibonacci number without going kaning ingani nga pagi, no? Without even solving the first katong terms before sa iyahang term. So this time, we will have the golden ratio and the Venice formula. So here, golden ratio, people, and the Venice formula are related to the Fibonacci sequence. So later you will know anong related sila. So observe the table, people. So the table, you have there your n, and then your Fibonacci number, the second column, and then the ratio between the Fibonacci number and the number before your n-1, meaning na if this is 2, then ang iyang n-1 is kaning sa 1 nga part, sa value niya. So if you could observe, people, so of course this is 1 to 20 ang imong n, yang imong f of n kay gina-follow gid nimo ang atong Fibonacci number, which is ang pinakalas is 6,765. Then observe sa third column, people, there is a certain number nga nagbalik-balik, no? Bantay mo. So in a value of 1.61803. So kaning nga value mao ni siya ang sige og balik-balik. No, once nga magadako imong number, mura siya og mupadung siya ana nga value. So if we could graph this one, no? If we plot the values in the third column as a line graph, we obtain this graph. So sa man yung nabatayan sa graph, di ba? Murag ni stagnant siya sa usa ka number. No, ni stop siya sa ka number. Bantay mo. So kung atong sabton sa people, as n gets larger, the values in the third column tend to converge at a specific value, which is 1.61803. So technically, if we say fn divided by fn minus 1 approaches to 1.61803, as n approaches infinity. So meaning, kung magkadako ang value sa imong Fibonacci number, people, kaning kani diri, no? Meaning na ang imong n kay approaches to infinity. So kung magkaduol imong number sa kaning 1.610. And then ang kanang 1.61803, people, naana siya ko kanang sa math path, importante kayo na siya nga value. Okay? So, mathematicians have worked on this ratio for hundreds of years, and they found out that its value, we rounded off to 20 decimal places. So you have here the 1.6108,398,7498948482. Or this is exactly the same with 1 plus square root of 5 divided by 2. And this number, people, is called the value of the golden ratio. Okay, and it's usually denoted by this Greek letter phi. No? So like the other mathematical constant, people, pi and e, the golden ratio phi is also an irrational number, meaning non-repeating and non-terminating decimal expansions. Yeah. So if siguro mo tanong mo may connect sa golden ratio o sa Fibonacci sequence. Okay, so here, people, let's try to, before we go sa katunga part, tinawo nga nganong nakaingon man sila nga ang kaning golden ratio, people, is the standard of beauty. So let's watch this. No? I don't know anong din na siya ma-view. Hala. Wala ko internet. Lang ha. Dili ma-view. Okay. Here, nanadira, no? Ato i-try view ang video, ha?
The worlds of architecture, design, and art may seem like open, creative endeavors, but they may not be quite as spontaneous as they first appear. When we look at great moments like these, there are similarities that we just can't ignore. All these instances adhere to the same compositional proportions. These proportions are known as the golden ratio. So what is the golden ratio? The golden ratio is a mathematical figure. It was first theorized by ancient mathematicians to quantify the beautiful asymmetry found in nature. Specifically, the golden ratio is equal to roughly 1.618. When the ratio is applied to shapes, like this square, you get a rectangle of harmonious proportions. When the original square is placed over the rectangle, you get a diagram that is representative of the golden ratio. Renaissance artists used the golden ratio extensively in their paintings and sculptures to achieve a sense of balance and beauty. Leonardo da Vinci, for instance, used it to define all the fundamental proportions of his painting of the Last Supper. However, these days it's debated whether the golden ratio is a true universal law. Over the years, Stanford math professor Keith Devlin has run an experiment. He's shown students different rectangles and asked them to pick a favorite. His finding? Students seemingly prefer rectangles at random, which could suggest that the golden ratio is not the subconscious standard of beauty that Greek philosophers believed. That said, ultimate truth may not matter. For artists and designers, the golden ratio can still be a powerful tool for creating aesthetically pleasing designs. Take the Twitter logo. Each part of the logo can be defined by circles that align to the golden ratio. Graphic designer George Bakua is known for modern, minimalist logos for clients and brands all over the world. When designing logos, he relies heavily on the golden ratio, and specifically its derivative, the golden spiral.
In my case, I love the shape of the golden spiral. The shape itself feels right, it looks good. I just use it whenever I can.
So, is the golden ratio true, or is it a myth? For designers and artists, it may be just one more tool on the quest for creative perfection.
Alright, so in the video, people, it was mentioned, no, that the golden ratio uses the katong tawag na to, the golden spiral, no, in which spiral and Fibonacci people are related. So in that case, we could say how this golden ratio and the Fibonacci sequence kay na-relate sila sa usap-usap because katong spiral niya nga form, which is Fibonacci is following this spiral from atong example atong sunflower configuration, people. So mao na nga using the golden ratio, people, we could compute the nth Fibonacci number without the actual computing the rest of the previous numbers before the nth number. So let's say, for example, if you were going to solve the 40th Fibonacci number, you didn't need to solve the 39, 38, so on padung sa 1 para makuha nimo ang ika-40. So we will be using the golden ratio to solve the nth Fibonacci number. So I'll explain to you ngano, no. So here, people, we will be using the golden ratio for a specific purpose, that is for the Benet's formula. So Benet's formula, people, is a special formula designed to give us the nth Fibonacci number without actually generating the first n minus 1 numbers in the sequence. So without this formula, if we are asked for, say, F20, we need to generate the first 19 Fibonacci numbers before reaching the 20, and then of course kapoy gid na siya. But using the Benet's formula, people, we can now solve the n Fibonacci number nga dili na hassle sa ato ang part. So this is now the formula of the Binet's formula, people, this is given by f of n is equals to 1 plus square root of 5 divided by 2 raised to the power of n minus 1 minus square root of 5 divided by 2 raised to the power of n divided by square root of 5, where the 1 plus 5 1 plus 5, sorry, 1 plus square root of 5 divided by 2 is your golden ratio, and then the 1 minus square root of 5 divided by 2 is the complement of the golden ratio. So the question is, sir, yun sa man pagkuha ni mga utanga here, diin man is lagikan. So this afternoon, people, I will try to show to you how this golden ratio, kaning value niya is being derived, no? So, allow me to share whiteboard, ha? Hello, nakita rin niyo ang whiteboard?
Kita na siya.
So, di ba, you mentioned it to people, nga naato siya itawag po katong rectangle, and then the rectangle is divided into two parts. The one part is small, and the bigger part is big, no? Tama, no? Takto ba? Okay, and then of course the golden ratio, people, is denoted by this kaning Greek letter phi is equal to a plus b divided by a. Sorry po, sorry, nalimot ko. Before na. So that is a divided by b, or simply equal to a plus b divided by a. So mao ni siya ang equation nga to ang ma-create out of this certain kaning figure, no? And then we could rewrite this into a over a plus b over a, in which ma-simplified na to siya into 1 plus b over a. So people, pwede tamingon nga phi is equal to 1 plus b over a. Now, if atong tinawon ang equation before here, no? Ang a over b, people, is equal to phi, o to siyang balihon, di ba? Now, karon, ang b over a is the reciprocal of a over b, in which mauna-unaan na to nga ang b over a, people, ang b over a is can be 1 minus p. So atong i-try og substitute, p is equal to 1 plus 1 minus p. Yeah, of course, automatic man gid na nato nga kinahanglan gid nato na i-simplify ang equation kay para dili siya murag samok tanawon. So we will multiply both sides by phi. So this become phi squared equals phi, and then cancel na siya, people. This will become 1. Nya atong i-try og equate to 0. So phi squared minus phi minus 1 equals 0. Nya automatic din na mususi mo na lang nga quadratic man ni sir. So ari ka sa a, b, and c. So find the value of a, 1. Find the value of b, negative 1. Find the value of c, negative 1. Ya, musuti ka diri sa katong kuha na to ang iyahang mga iyahang mga values no 0. So bingon ni ka dira nga negative formula para makuha ang iyang 0, sir. So you have now negative b plus minus square root of b squared minus 4ac, diba? Then divided by 2a. Sakto dili? Sakto na lang, sir. Okay, para maumanak ka. No? Alright, come on. So ato i-substitute, people. So you have negative